Hello dear students, I hope you are doing well. In this video, we are going to discuss the exercise 5.5 using logarithmic differentiation, and this exercise is from the chapter Continuity and Differentiability. So before that, let us see what is logarithmic differentiation. So till now you have got functions like f of x, f of xy, and we have done the derivative of such functions. But if we have a special kind of function like f of x is equal to ux to the power vx, then how to do? In such a case, we can use the logarithmic differentiation here. That means if you take the log on both sides, so we should have log fx is equal to log of ux to the power vx. Now by the property of log, what we have, log of fx will be equal to, this power will come in the left hand side, or and it will come at the bottom. This will be vx log of ux. Fine. So now it can be easily differentiable. So using this property, let us see a few problems from the exercise. Let's see the first one. Here the question is given cos x, cos twice x, and cos thrice x. So let us write that y is equal to cos x, cos twice x into cos thrice x. Now either we can directly do the differentiation of this by using chain rule, or another option is that you can take log on both sides. Taking log, this always remember that this log will be of base e, right? Taking log on both sides, we have log of y is equal to log of cos x, cos twice x, cos thrice x. Now, what is this equal to? We have got that the property log of mn is equal to log n plus log n. So you can use this property here. These are in the product form. So this will be equal to log of cos x plus log of cos twice x plus log of cos thrice x. Fine. Differentiating with respect to x, we get, if we differentiate this with respect to x now, so this will be 1 by y, because ddx of log x is 1 by x. So here we have log y 1 by y, but y is not x, isn't it? So we need to write dy by dx, or ddx of y. This equal to, so again if I take the differentiation of log cos x, so consider the cos x as x here. So this will be 1 by cos x. Using the formula ddx of log x is equal to 1 by x. So we are using that formula here. Now cos x is not the x again, so we have to write ddx of cos x plus, similarly here we need to write cos twice x, log of cos twice x 1 by x. Again cos twice x is not the x, so we need to write ddx of cos twice x plus 1 by cos thrice x and ddx of cos thrice x. This implies 1 by y dy by dx is equal to, what is this, 1 by cos x, and ddx of cos x is minus sin x plus 1 by cos twice x. Again ddx of cos twice x is minus 2 sin twice x, and ddx of cos thrice x will be minus 3 sine 36. Fine. Now take the y that side, which will be dy by dx is equal to, if I take the y that side, it will be y into minus sine by cos will be minus 10 x. Here also we have minus, so minus 2. Sine twice x by cos twice x will be twice 10 twice x minus 3. Sine thrice x by cos thrice x will be 10 thrice x. And this can be written as dy by dx is equal to, so in place of y, what is our y? It is cos of x, then cos twice x, cos thrice x, and multiplied by this whole thing. That will be minus 10x minus twice 10 twice x minus thrice 10 thrice x. So that will be the answer. Next, let us see question number 9. So question number 9 says x to the power sine x plus sine of x to the power cos x. Okay. So for that, let us consider y is equal to x sine x plus sine x cos x. Okay. So you can notice one thing there. If I apply directly log here, we do not have any formula of log like log of a plus b. We cannot expand it. There is no such formula, because log of ab gives us log of a plus b, but log of a plus b there does not lie any such formula. So for that, let us consider this implies y is equal to u plus b, where u is equal to x to the power sine x and v is equal to sine of x whole to the power cos x. So we have considered these two as u and v. Fine. Now, therefore, what would the derivative? Dy by dx will be equal to du by dx plus dv by dx. Okay. Now it is a bit easier. You can see if I find the du by dx now and dv by dx, our work will be done. Okay. So now here we have u is equal to x sine x. If I take log on both sides, so taking log on both sides, we get what we shall get. Log of u will be equal to log of x to the power sine x, and this will give us log of u is equal to sine x will come down, it will be sine x log x. Now if I differentiate this, differentiating with respect to x, what we shall have, we get log of u will be 1 by u, but u is not x, isn't it? So we need to write du by dx, and here we shall have, see, this is a product function, that is ddx of, we have ddx of uv is equal to u v dash plus v u dash. So first function into ddx of second function, that is first function ddx of second function will be 1 by x plus second function, that is log x, into ddx of first function, that is sin x will be cos x now. Fine. So this gives us du by dx is equal to, if I multiply the u up here, so we shall have u, this will be sin x by x plus log x cos x. This will give us du by dx will be equal to, what is our u? It is x to the power sin x, and here we should have sin x by x plus log x cos x. Fine. So can I simplify it? Okay, let's leave it up to this. Next, let us see the case for v. We have v is equal to sin x whole to the power cos x. Okay, so if I take log on both sides, we shall have log v will be equal to cos x log of sin x. This cos will come down. If I differentiate it, differentiating with respect to x, we shall have log v will be 1 by v dv by dx, and this will be, see here we have, yeah fine, this is one function and this is second function. So first function, write the first function first, then dx of second function, that is log of sin 1 by x will be, log of sin x will be 1 by sin x, but sin x is not the x, isn't it? So we need to write the dx of sin x here. Clear? Plus second function, that is log sin x into the dx of first function. So what is the dx of first function? It is cos x, so it will be minus sin x. Fine. So remember, these two are in the multiplied form, these two are in the product. Okay, so this gives us 1 by v dv by dx will be equal to cos x by sin x will be cot x, and dx of sin x will be cos x, minus, if I take the minus here, it will be sin x and log sin x. I can give you a bracket here, that will be better. Okay. So now take the v up. So this will be dv by dx will be equal to, if you take the v up, what is our v? If I write it directly, this will be sin x to the power cos x into cot x cos x minus sin x log of sin x. Fine. Okay. So therefore, from here, what I can write, we had dy by dx is equal to du by dx plus dv by dx. So we have got du by dx equal to this and dv by dx equal to this. So we can write dy by dx is equal to, what is our du by dx? It will be x to the power sin x into sin x by x plus log x cos x plus sin x whole to the power cos x, or sin x to the power cos x into cot x cos x minus sin x log of sin x. Fine. So this is our answer. Now let us see question number 12. It is given x to the power y plus y to the power x is equal to 1. So here we need to find the so next we have question number 12. Here it is given x to the power y plus y to the power x is equal to 1. So here we need to find the dy by dx. So clearly we can see that this is an implicit function because we cannot separate the y. Okay, so x to the power y plus y to the power x is equal to 1. So here I can write, let u is equal to x to the power y and v is equal to y to the power x. Therefore, if I give it equation 1, Therefore 1 implies u plus v is equal to 1. So taking derivative or differentiating with respect to x, that will be easier. Differentiating with respect to x, what we shall have? We shall have du by dx plus dv by dx will be equal to ddx of 1, isn't it? And what is this? This will imply du by dx or ddx of u plus ddx of v will be equal to ddx of 1, and 1 is a constant, so I can write as 0 here. Now if I am able to find the ddx of u and ddx of v, so we are done. We can add them and get the desired answer. So from this part we have u is equal to x to the power y. So we can see that this is clearly the function that we are discussing, so we can use the logarithmic differentiation here. So taking log on both sides, what we shall have? We shall have log of u is equal to the y will come down, y log x, fine, and differentiating with respect to x, we shall have, if I differentiate the whole thing with respect to x, then log of u will be 1 by u, because we know that ddx of log x is 1 by x, but this u is not x, isn't it? It's a function of x. So we need to write ddx of u. This will be equal to, you can see this is the product form, that is y into log x. So let's do it. So first function into ddx of second function. Second function is log x, so we can write 1 by x. And since it is x only, so no need to do this second part, or no need to differentiate x again. Plus second function, that is log x, into derivative of first function, that is dy by dx or ddx of y. Fine. Now this implies, if I multiply the u there, so dx of u, the u will go up here, so we shall have y by x plus log x into dy by dx. Fine. So this will give us du by dx is equal to, what is our u? U is x to the power y into y by x plus log x into dy by dx or ddx of y. Fine. So keep it up to there. Now let us see for this being v is equal to y to the power x. So given this, then taking log on both sides, we shall have log of v is equal to x will come down, x log y. So differentiating with respect to x, what we shall have? We shall have 1 by v dv by dx will be equal to x, just a minute, okay, so y to the power x, yeah, fine, and earlier one was, yeah, fine. So first function ddx of second function, that is, it will be 1 by y and ddx of y, because y is not the x, plus second function, that is log of y, into ddx of first function. So first function is x, so ddx of x is 1. Okay, now this implies dv by dx will be equal to, if I take the v up here, what is our v? It is y to the power x. You can directly write y to the power x, x by y, dy by dx plus log y. So we have found the du by dx, that is ddx of u and ddx of v. Now just put these two values over here. If I take it equation 2 and this is equation 3 and this one is 4, so using 3 and 4 in 2, we shall have, what is our du by dx? It is So this one was equation 3. So we can write x to the power y into y by x plus log x into dy by dx plus y to the power x by y dy by dx plus log of y, and that will be equal to 0. This can be written as, we need to find the dy by dx, isn't it? So this can be written as, if I multiply this, x to the power y minus 1, because we have x to the power y and there is a x in the denominator, so there will be x to the power minus 1, so I can write it together, into y plus x to the power y log x dy by dx, and this can be written as y to the power x minus 1 into x dy by dx plus y to the power x log y, and that will be equal to 0. Now we need to find dy by dx, isn't it? So just solve for that. So take dy by dx common. So what we should be left with? X to the power y log x plus y to the power x minus 1, or xy, xy to the power x minus 1, x into y to the power x minus 1 plus, so the remaining thing, the terms without this, so x to the power y minus 1 into y plus y to the power x log of y, and that will be equal to 0. Now this will imply dy by dx will be equal to, if that goes in the left hand side, so we shall have a minus here, so this will be x to the power y minus 1 into y plus y to the power x log of y, and if I divide it with this, so this will be x to the power y log x plus xy to the power y minus 1. So that will be the answer. So we have successfully found the derivative of y, and we have one more question, that is question number 17. So they have given the differentiating two polynomials, multiplication of two polynomials in 3 ways mentioned below, that is by using product rule, by expanding the product to obtain a single polynomial, and by logarithmic differentiation. And we need to check that whether 3 of them give the same number or not, or same answer or not. Okay, so this question will be your assignment. I shall give it in the assignment also. So that will be the end of chapter or your exercise 5.5. So in the next exercise, in the next video, we shall come up with derivative of functions in parametric forms. So till then, practice all the problems from this exercise and stay home and stay safe. Thank you.